Good morning, everyone. Today I will teach you the Fourier transformation. So, first of all, we have learned you have learned the Fourier series in previous semester. So, what was the series? That is a function. If a function that is periodic function, ft, that is periodic. The periodic in the interval 0 to t. So this function can be written as like that: a0 by 2 plus summation over an cos n omega t plus bn sin n omega t, where summation goes n is equal to 1 to infinity. And we know the coefficient a0 is equal to 2 by t integration limit 0 to t ft dt, and an 2 by t integration over 0 to t limit 0 to t ft sin cos n omega t, and bn the 2 by t the integration over time dt limit 0 to t if into the function is ft into sin n omega t. So this three integration will give us all the coefficient a0, an, and bn. Now if I change the limit in this integration, that is minus t by 2, from minus t by 2 to t by 2, the total time period t here the same as previous, then the coefficient, all the coefficients can be written as like, where all the same, just we have changed the limit 0 to t. We have replaced this by minus t by 2 t by 2. Okay, now I want to change the term sin cos n omega t and sin n omega t, just using the exponential form. So sin n omega t is nothing but that expression, and cos n omega t is nothing but that. So if I put sin n omega t and cos n omega t, then ft can be written as that. And if we rearrange, just here the coefficient of e to the power I n omega t have been separated out. Similarly, here the coefficient of e to the power minus j n omega t has been separated out. Now if I define c0 is equal to like that, a0 by 2, and cn is that, and cn minus is like that, then we will get this expression. Now if suppose this n is a dummy variable, so you can change it m, and that is minus n is equal to m, then limit will be minus infinity to plus minus infinity, minus 1 to minus infinity. But if I change this minus n to m, so that will be cm, and that will e to the power j m omega t, and limit will be minus infinity to minus 1. So in the both case, the limit will be minus m into minus 1, where m is equal to 1 to plus infinity. So minus 1, in between minus 1 and minus 1 and plus 1, there is a term 0, that is a0 or c0. So that is, so if I combine, we can recombine combining these three terms, so we can write this summation. Now we have applied some tricks. So if I multiply by t and also divided by t, then t is, if I replace the t by omega by 2 phi, then we can write that Now we know, sorry, sorry. Tcn is f omega and omega is equal to delta omega. What is the delta? Delta was the fundamental frequency, and that is for first harmonic, frequency of first harmonic, and the frequency of second harmonic 2 omega. Similarly for third harmonic 3 omega. So the difference between two successive harmonic is nothing but omega, that is delta omega. So I replace delta omega in terms of delta omega. I can write the ft like in that way. So if I put the limit t is equal to infinity, that is delta omega tends to 0. So we can get so I am wrong, I was wrong. So I'll get that. So this integral gives this function will give this integration. So as we know, ft is equal to like that. Here what we have done, we have changed the omega to omega 1, that is dummy variable, that is the integration over d omega. So we can change the variable, that is dummy variable. So if I multiply both sides by e to the power minus j omega t, and if we take the integration over time from minus infinity to plus infinity, then we will get that. So that now what we have done, thus I have taken out d omega and f omega, and just we have now we are integrating over time. So this integration over time will give me the d omega. Okay, delta, so delta function. So we can write that is, so if I use the properties of delta omega, that will give me the f omega, that is this integration will only give the value when omega is equal to omega 1. So we can write f omega is equal to like that, and ft is that. So here what we have noticed, that there is a factor 1 by 25, but there is no 1 by 25. So it is customary to express this relation in a symmetric form, that is f omega is equal to 1 by root 2 pi, that is the integral same, and f is 1 by root 2 pi, and that here f omega is the Fourier transform of ft, and ft is the inverse Fourier transform of f omega. That's it. Thank you.